Hey guys, sorry to miss being there with you all today. Hope you arrive safe and you're enjoying your short day. Just Nola has this cold that's not going away, so I'll be staying home, taking care of her today. And hopefully I'll see you again real shortly. We got to finish up what we were working on last week at the end of the week, whatever day I saw you last. I can't remember anymore. But first, a joke. How do you track down Will Smith in the snow? You follow the Fresh Prince. All right. So remember we were talking about, you guys were collecting data on the Barbie bungee jump. Should have identified the explanatory variables being the number of rubber bands and the response variables being the distance traveled. And of course, those are two quantitative variables. And I should have made a scatter plot from your data. Of course, it won't look exactly like this. It probably didn't turn out as nice and perfect like this, but oh well. Just use your data. But on the vertical axis should be the distance traveled, since that's our response variable. That's one where that will go, since it's kind of more like our dependent variable. And then, of course, on the horizontal axis should be the number of rubber bands, since that's the explanatory variable. And that should be typical, or the way you should always see it as far as where those go. And so we want to describe this relationship here. And it goes on kind of like we did when we were describing the graphs, but way back in Unit 1. It's a little bit different, but there is an anagram to help you guys, not anagram, acronym, to help you guys remember the four kind of criteria for describing a relationship here, and it's DOFs. And so that stands for direction, outliers. So there's a common form, and then strength. So when we talk about direction, it'll be something like positive or negative. The outliers, of course, are our outliers. Form is going to talk about like if it's a linear relationship or a nonlinear relationship. And then strength would be something like if it's got a strong relationship, a moderate relationship, or a weak relationship. We'll get into some of these details more later. That's what you're after. And so as we look at this graph, for mine in particular, it's all super perfect. Everything's falling in a nice straight line. Yours probably didn't do this. And then there might be some scattering and stuff like that. So that'd be, and then notice how the more rubber bands we used, the more the doll traveled. So that'd be a positive relationship. You guys should have all definitely seen a positive relationship. The less rubber bands you use, the less it traveled. The more rubber bands you use, the more it traveled. That's a positive relationship. So less rubber bands meant less distance traveled. And more rubber bands meant more distance traveled, or greater distance traveled. Outliers, so this, I don't really have any outlier. So to say that, if you saw something along the lines of, this, where something's way out here, you would just mention that there seems to be an outlier at 2 rubber bands, only going 10 centimeters or something like that, but we don't have that. So no outliers. There appear to be no outliers is what I would say. Forms. This is again linear or nonlinear. So this definitely for this one would be a linear pattern. So as long as it's like going increasing rapidly, then all of a sudden like slowing down and like starts increasing again. Like that would be something that's nonlinear. So even there's things that like don't form like straight lines can still be considered linear. So something like this, even like this, would be considered linear because it doesn't. The overall pattern doesn't go up and then down or twist. So it seems like the overall pattern is a general. As one thing is going up, the other thing is going up, or even the other way around. Like if the data was decreasing, so a negative pattern, but still it's in general it's it's not bending like this. So it doesn't have to be a perfect line in order to be linear, but we're just noticing there's not like a twist or a change in the again the general shape of it. So. So it appears to be a linear pattern, or there's a linear pattern to the data. And then the last thing, the strength. Again, for this, we're looking at this relationship here would be very strong. Everything seems to be like in a nice tight bunch. Again, we'll look at other things later, but something like this might be like a moderate strength. Again, where things are pretty close to the middle, nothing's getting really crazy off. You could even have something along the lines of so as you start to spread things out a little bit. So if your data looked more like that, maybe that's like a moderate strength relationship. But mine would be a strong relationship. Because the points form a nice tight line. So that's what that should look like. Again, the acronym there is DOFS. You don't have to write everything in that order. I think it's actually kind of a little clunky to write in this order. Probably I would go more along the lines of like direction, form, strength, and outliers. Probably the last thing I mentioned, but just a good way to remember the 4 things that you need to talk about. So here's the quick notes, and of course you guys can make with the pausey pause to get that copied down. Again, just where do we put the response variable? Where does the explanatory variable go? Again, the different points to hit during the description. So, again, this little tip that you're using both variable names as context when you're writing your description. So, let's get that copied down, then we'll look at the example here. So what we're looking at here is some data about the amount of sugar in different candies and then the amount of calories in those candies, and they're asking us to figure out if there's a relationship between the amount of sugar in the candy versus the amount of calories in the candy. It certainly would seem reasonable to assume that more sugar something has, the more calories it has. So go ahead and make a scatter plot for that, or you can copy mine down, but just use the applet if you wanted to. But here is the scatter plot that would come out of that. So just noticing that if, amount of sugar would be my explanatory variable, and the amount of calories or the number of calories would be my response variable, that I would expect this one to predict this one. Do notice that the axes have not started at 0. We won't have any data down there, so it'd be kind of a waste of space, to have all this. If it looked like this, and the dots are all just all up, up in here, like. So the axes do not need to start at 0, just like when we did a dot plots, they didn't have to start at 0 or anything like that. So they're really just trying to use up the spaces as well as possible. So you do not need to start at 0 down here, but the scale does need to be nice and consistent as you're drawing it. So make sure your gaps are even, and the same space between them, as far as physical space and numerical space between them as you're drawing them. So something to watch out for. Maybe we can get that copied down, just to the best ability, those approximations. But then we want to describe it. So I'm thinking about my DOFs, right? So again, kind of starting with the direction, is that there is a positive association. The more sugar there is, the more calories there tend to be. So starting off with that, so direction is going to be a positive association. I'm going to go into form, right? What type of pattern is it? So here again, you may not look at this and see this as linear, but again, the idea is that it's not, going up and down or something like that, or even just like going up sharply and then kind of slowing down. Like that's not there's a bend there, and so even if you don't think it's linear, just that idea that you guys have heard about a line of best fit before. Something maybe along those lines would help us see that. So a linear pattern here. So we start to see a lot of variance here, especially as we head off this way. So I think there's not a great strength here. So it's, I'm not gonna say this is strong. Weak would probably be more scattered than this. If I had points up in here and points down in here, like things that have more of a weak pattern. So I'm going to say this is a moderate strength pattern. And then outliers, right? Does there appear to be any outliers? This one up here definitely seems to be quite a bit off from the rest. That's at about 79 grams to 800 sugar, which is looks like the M&Ms. So I'm going to go ahead and write my description here. So we said this was a positive relationship. Between sugar and calories. The candy with more sugar tends to have more calories. And the candies with less sugar tends to have less calories. So there's kind of my idea, and then why I'm saying that, right? My explanation behind that. And then the form, this has a linear pattern. So you could say to the data or to the scatter plot. We could say, and then the next was the strength. So I'm saying this was a moderate strength. And there's because the points are somewhat scattered or vary somewhat from the pattern. And last thing was the outliers. So there appears to be an outlier. The peanut M&Ms appears to be an outlier. And giving its location and give its information. And that's it. So you guys have the 3-2 homework. Should be turning in the 3-1 homework today. So go on to the Schoology and find the 3-2 assignment. Tomorrow, or next time I see you, I'm going to go over 3-2 just in some more detail to help you guys, tighten up these descriptions of the relationships and look at some different patterns, since there's not been a lot of variance here in the examples and the notes and stuff like that. So I want to go over some examples together. So hope you have a wonderful rest of your day and stay safe. And I forgot to tell you, I've been teaching Lou, my dog, how to count and do math, like some simple math. So yesterday I asked him, what's 2 minus 2? And he said nothing. All right, I'll see you guys.